All right. So how do we check if something is linear when given information like this? We already know what it looks like when it's graphed. We already know what it looks like when they give us um, the equation. But how can you tell from here? Now, linear means that it's consistently following the same path. So the slope has to be the same consistently. So let's first check what the x increases. So every time we went up 3, this one went up 3, this one went up 3, and this one went up 3. Okay, so that's consistent, going up 3. So that means that this one has to be the same thing over and over again. So this one is down 2, down 2, down 2, and down 2. So the slope of this is negative 2 over 3, negative 2 over 3, negative 2 over 3, negative 2 over 3. So slope is the same every single time, which means, yes, it is linear. It's consistent, straight line. Now, if they add more points, then maybe it will change, but from what they give us right here, it is linear. Let's check this one. This one goes up 2, up 2, up 2, and up 2. So then this one's going to make, this one's also up 2, up 4, up 2, and up 4. So that's 2 over 2, 4 over 2, 2 over 2, 4 over 2. So the slope is changing. It's 1, and then it's 2, and then it's 1, and then it's 2. That's not a straight line. So this is nonlinear. Okay? So it has to make the same slope over and over again. So you see that it's 2 over 2? If I made this 7, okay, that would have been 2 over 2, which is 1, and 4 over 4, which is also 1. So this wouldn't have been part of the why it's nonlinear, okay, because it makes the same slope. 4 over 4 is also 1, so the slope would have been more consistent. I would have had to change another one as well, okay, but that I'm not going to do that. This is still nonlinear because of this right here. The 4 over 2 means 2, so the slope is different. All right, so how do you find the slope when you're given 2 points? There are 2 methods, okay, the method taught in the book and the method that I did. So the formula for slope is y2 minus y1 over x2 minus x1. Okay, just in case you don't know, the first point you run into, that's x1, that's y1, this is x2, and this is y2. Okay, so it's going to be these 2 in the front. So it's going to be 1 and then 5, and then 2 minus signs, and then negative 2 down here and 0 up here. Now, negative and a negative, when one number has 2 signs in front of it, it's going to make, well, if it's 2 minuses, it's going to make a plus. But you have to change it. You don't want to be left there with 2 signs. It'll throw you off. So now we just do 5 minus 0. That's 5 on the top. And 1 plus 2, that leaves you a 3 on the bottom. There's your slope. Not that bad. You just have to put the right numbers in the right location. Now, the other formula that I do is the change in y divided by the change in x. So how much does y change? So y went from 0 to 5. So it went up 5. So positive 5. X went from negative 2 to 1. Okay, so negative 2 all the way went up 3. So here we go. And that's it. My slope is 5 over 3. If it would have gone down, I would have written it as a negative. So that's how you do slope. So for this one, it reads, here are the 2 points, and here's the slope it has to make. So we know that the formula is, so remember, x1, y1, x2, y2. So it's going to be these 2 in the front, negative 5r, and then minus minus, and then these 2 points, 1 and 4, right? So, and this has to make the slope 1 over 3. Now this bottom one, obviously, is going to make negative 6. So it's r minus 4 divided by negative 6 equals 1 over 3. So how can we make sure? There's 2 fractions and an equal sign in between. We already know how to solve this. You cross multiply. So it's going to be 3 times all of this So 3r and 12 equals negative 6 times 1, negative 6. Add 12 to both sides. You're left with 3r equals positive 6. And then divide by 3 on both sides. R equals 2. Okay? You can check your work by putting 2 in the equation. 2 minus 4 is negative 2. Is negative 2 over negative 6 the same thing as 1/3? Yes, it is. Okay, you can cross multiply to check. That's going to make negative 6. That's going to make negative 6. All right. Over here, all right. This is a direct variation. How do I know they're direct variations? They're going through 0, 0. Okay? That means they follow this formula. Y equals kx. K is the slope. Okay? What's easy about these, okay? We'll do the black line first. What's easy about these is that any point, except for 0, 0, any point that's on this line is the slope. Okay? So what's the slope for the black line? The slope is 2 over 3. Remember, it's y over x. That's the slope. So what's the equation? That's the equation. Okay? For the purple line, it's going to be negative 2 over 1. Okay? Because it's going through 0, 0. It follows that rule. Negative 2 over 1. So the equation, negative 2 over 1 is actually negative 2. So we'll just leave it as negative 2. So the equation is y equals negative 2x. Very simple to grab it from here. If it goes through 0, 0, that's the way the equation looks. You just put the slope here. How do you find the slope? You find any point that isn't 0, 0 on that graph line, that's going to give you the slope. All right, here's an equation that comes from here. So y varies directly with x, which means you're dealing with this equation. Okay? Y equals kx. Okay? And they give you, so this is a direct variation. And they give you a point, which means you know the slope. Y equals 72 over 8, which is actually 72 over 8 actually is 9. So y equals 9x. So I know the formula. This gives me the slope. They gave me a point. Just like in the graph, you can grab it and put it right there. Then find x. So you're looking for x when y equals 68. Okay? So y equals 68. Right? Let me just, I think that's the question. So if y equals 68, I'm going to replace y with 68. So where the y is, okay, I'm going to replace it with 68. Okay? Equals 9x. Now we just have to divide by 9, and that's going to be our answer. 68 divided by 9 is going to be 7. 7 times 9, that's going to be 63. That's going to leave me with 5. We're going to put a decimal point, bring down the 0. 50, that's going to make it 5 is too much. Oh, 5. So 5 times 9 is 45. Subtract, that's going to be a 5 again, so that's going to be 5 forever. So 7.5 forever will give me my solution. Okay, if we round, it'll be 8, but we'll just leave it like that. I should have put 63 here instead of 68, but that's fine. Sometimes you get weird ones. All right, not that bad. And then here, arithmetic sequence. Okay, is it arithmetic, yes or no? It has to follow a consistent pattern of adding or subtracting for it to be an arithmetic sequence. So this first one, let's check. It goes down 2, then down 1, and then down 2. Not consistent. So that one is not arithmetic. This one, it goes up 5, up 5, up 5. This is an arithmetic sequence. Okay? This is an arithmetic sequence. So let's write the equation for this arithmetic sequence. Okay? I need to write an equation that answers for all the arithmetic. Okay? So for number 1, I'm going to write n to tell you what number I'm talking about. So number 1, the first one, is 4. Number 2 would be 9. Number 3 would be 14. And number 4 would be 19, and so on. Okay? So the arithmetic sequence for any number is written like this, with an A and then an N. Telling somebody that's an arithmetic sequence, why is that important? That means that you can't use 0, you can't use -1, because the first number is the first. There's nothing behind this. It's n equals 1, the first number. So arithmetic sequence tells you that there's no 0, there's no negatives. You can't plug in any of those numbers into n. Okay? Now the slope, okay, is the rate in which it increases consistently. So 5 is the slope. All right? So 5 times any number, okay? Let's see if 1 works. I'm going to put number 1. If I put number 1 in here, the answer should be 4. Okay? So 1 in here. 1 times 5, does that equal 4? No. Which means something is happening over here. Okay? So something is occurring over here. All right? According to this, the answer should have been 4. The answer should have been 4. I'm getting that right here. Okay, the answer should have been 4 if I use the number 1. Number 1. Okay? What's the first one? It has to equal 4. Okay? So something is changing it to work. So let's see, 5 times 1, that's 5. I'm going to subtract 5 on both sides. I get -1. And b is by itself. So -1 equals b, which means this over here, this plus b, is supposed to be -1. And this should tell us the solution for any number in here. So if I'm looking for number 3, okay, if I'm looking for number 3, I'll put a 3 in there. So let's see. If I put a 3 in there, what's the answer for number 3? Let's see what the answer is for number 3. 5 times 3 minus 1. It's supposed to equal 14. We'll check right now. 5 times 3 is 15. 15 minus 1 equals 14. And that's the answer for number 3. That's correct. The answer for number 3 is 14. So this formula works perfectly for any answer. Okay? The answer for any number in the arithmetic sequence equals 5 times whatever number you're looking for minus 1. So if you're looking for number 2, you put a 2 in there, times 5 minus 1, the answer is 9. Boom, it's right there. And this will help you. What if I'm looking for 100? Are you going to add 5 100 times? No, I just put 100 in there. It's going to be 500 minus 1, 499. Super easy, super fast. Okay? And that's it.